Welcome to Secret of Mathematics and Physics. In this video, we are going to learn the topic geometric progression. It's also known as GP. And the part we are going to consider in this video is sum of a geometric progression, GP of GP. That is the one we are considering in this video. Now we have question given here, which is the sample, the fifth and third terms of a geometric progression GP are 48 and 12 respectively. Find the sum of the 6 terms. Now, what can we do here? The first thing to do is that to bring out the data given. Now we have fifth term, which is T5, which is equal to, as the first mentioned here, 48. The third term now to 12 respectively. Now find the sum of the 6 terms. We're looking for the sum of 6 terms. This is x6. That's what we're looking for. Now, as we bring out the data given now, let's look for the first one, which is the 10. Let's write out the formula. We have the nth times formula now, which is T. This is the formula we are going to apply to and the first term. Now, let's substitute the first one, which is the fifth term. Now, we have one ratio raised to power n term, which is 5 minus 1, and everything will be equal to 48. Right, here will be equal to a first time multiplied by the common ratio. Right, 5 minus 1, that is 4, will be equal to 48. So let's call this equation 1. Now we come to the second one now, which is the third term, which applying this formula, which is n, which is 3 minus 1, and will be equal to 12. Alright, it will be common, the first term multiplied by the common ratio, which is 3 minus 1, that is 2, will be equal to 12. We call this equation 2. Now let's bring the two equations together. Next step that you can take now is by divide equation 1 by equation 2. 48. So this, we cancel this. A, we cancel A. 48 divided by 12. We have r raised to power 4 divided by r raised to power 2. Now, I'm going to apply, this is one of the rule of indices. If we have a raised to power 4 over a raised to power 2, now the result will be equal to a raised to power 4 minus 2. So which will give you a raised to power 2. So I will apply this rule here of indices. That's what I will apply here, right? Which is will be equal to 4, right? So r raised to power 2 give you 2, which is will be equal to 4. Now let's take the square root of both sides. Is r, there will be r raised to power 2 multiplied by 1 over 2, which is this 1 over 2 represents the square root, right? So here will be equal to, you can still rewrite as 2 raised to power 2 here, which is the 4, right? Multiplied by the square root of. So here we cancel here, cancel here, here cancel, here we cancel 2 here. So we have comma ratio now, R will be equal to 2, right? We have the comma ratio as 2. Now, let's substitute the comma ratio into any of these equations, but I would like to use equation 2, right? Right. So, but we have the value of comma ratio, which is R already, right, as 2. A now will be equal to 12. When you divide comma ratio R, we have 12 divided by R squared, right? So we have the value of R as 2, which is 12 divided by 2 raised to power 2. And we know that 2 raised to power 2 is 4. 2 raised to power 2 is 4, which is 2 divided by 4 is 3. Therefore, A first time will be equal to 3. Right. Now, the next thing to do, we are going to do for the sum. Now, find the sum of 6 times, which is this. Right. So let's write the formula out. Now, let's substitute that. We're looking for the 6 terms, right, of it, which is x6 will equal to the first term, which is 3. Yeah. Right. The first term is 3. Ratio, which is 2. Yeah. Right. Which is 2. And the 6th term, which is we have 6 as n time. Right. 6 2 raised to power 6 minus 1 divided by the comma ratio, which is 2 minus 1. Right. Now here will be equal 3 multiplied by 2 raised to power 6 is 64 minus 1 divided by 1. So here will be equal 364. 64 minus 1, that is 63. Now we have the sum will be equal to 3 times, right? So 3 times 63 should be equal to 18. Therefore, the sum of 6 terms now, the sum of 6 terms will be equal to 189. Thank you for watching.